Containers. What are they for? Why do we use them? Here's the challenge, is that there's a whole lot of software that you want to be able to run on platforms. So there's app servers and web servers and messaging systems and identity management systems and just all kinds of different software that you might want to be able to run as part of your application. And then meanwhile, there's all kinds of platforms that you want to be able to run it on. You want to be able to run it on your local machine. You want to be able to run it in the cloud. You want to be able to run it in your data center. You want to be able to set up multiple environments for HA and disaster recovery. You want to be able to run it on different OSs like Linux and Windows and Mac OS. And what you end up with here is a combinatorial explosion, which is that you've got all these different pieces of software that you want to be able to run, and you've got all these different platforms that you need to be able to run it on, and trying to set up each piece of software so that it'll run on each different platform gets really complicated really fast. And you end up wasting a lot of time trying to get all these different combinations working and try to even weigh which ones are the important ones, which ones should you get working first. And of course, any ones that you sort of say, well, we'll put this off until later, well, inevitably that turns out to be a really important one that you need to have. So it's kind of a losing game to try to support all these different combinations. We need some better way to kind of manage all this. Well, with Docker, specifically, containers in general, but this is specifically a statement around Docker, is Docker gives you an incredible amount of portability. So basically, you take all these different software units and you wrap them up and package them as Docker containers. So the beauty of a Docker container is it can run just about any piece of software. Basically, what it usually runs is a single process, and that process is running in Linux on the Linux kernel. And so pretty much any piece of software that you can run in a single process in a Linux kernel, then you can package into a Docker container. And for that matter, if you have software that requires multiple processes, then usually the way that goes is you put each one in a different Docker container and you just run multiple Docker containers. So again, as long as your software can run on Linux, you can pretty much package it up as a Docker container. Then meanwhile, what Docker has done is they've developed the Docker image or the Docker engine to run on lots of different platforms. So lots of different OSs like Linux, and then they kind of simulate it on Mac OS and on Windows. And it can run on desktop machines and data center machines and cloud machines. And when you're doing multiple environments for HA and DR, it can run on all of those usually. And so the beauty is that by taking your software and wrapping it up into a Docker container, you can then very easily run it on any or all of these platforms. That it makes it very easy to deploy to any of those platforms and start running it there. And it runs pretty consistently. So once you understand how it runs on one platform, assuming that's what you wanted, then you can fairly easily run it on a bunch of other platforms and it'll run pretty much the same way. And so you get a fair amount of consistency that way. So really, this reminds me of the whole Java story back when Java first came out. Is we said write once, run anywhere. What we found in practice was it's kind of write once, test everywhere, make sure that it actually runs everywhere, and make sure it runs the way you want to everywhere. But still, Java made applications very portable, such that you could develop them once and then run them on lots of different platforms. Well, Docker kind of takes that to the next level and says, instead of a virtual machine, what we're going to have is the Linux kernel and the Docker engine. And this way, anything that runs in the Linux kernel, you can run on any machine that has a Docker engine. So it's the same sort of idea, but it's more general than Java. And it's a pretty cool approach. It's pretty darn helpful. And a lot of this is true for containers in general, Linux containers in general, but especially for Docker, because Docker supports so darn many different platforms. And a lot of other container technologies don't support this wider range. They're a lot more specific. Another nice thing about containers, whether they're Docker containers or just other kinds of Linux containers, is they form a fairly clear separation between dev and ops. And that's kind of an interesting thing to say, because a lot of the idea behind DevOps is to bring dev and ops together and make them work together better. And usually those are two separate teams, and you want to make those two teams of people work together better. And that's still true, and we're not saying anything against that. But at the same time, it turns out that when you're using containers, then it forms a fairly nice separation between what dev is responsible for and what ops is responsible for. And so that you still want the two teams to work together, but at the same time, you don't want them spending all their time squabbling about who's responsible for what. So containers form a fairly clean separation that can work pretty nicely. And long story short, with dev and ops, dev worries about the stuff that goes inside the container, and then ops worries about running the container, the stuff that's outside the container, the environment that the container is running in. So dev gets to worry about, well, what language do we want to write the application in, and what libraries does it need, and what runtime does it need to run in, what operating system do we want to use. The operating system, for all practical purposes, is basically Linux. So it's a question of which variety or which flavor of Linux you're going to use. But dev gets to worry about all that kind of stuff, especially what language you're using and what runtime it needs, and how to configure all that. And dev worries about how they want that to be and then puts that inside the container. Then ops just says, all right, you've given me a container, and for the most part, I don't really care what's inside it. As long as it's not something really ugly that's going to like suck up all the memory on the machine or something like that. I don't need to, as an ops person, I don't need to worry too much about what's inside the container. It's just some process running inside of Linux, and hopefully that's a good thing. And so I'm going to worry about how to deploy it on the different platforms that I need it to run on. So I'm going to worry about all the external things that are part of how you run an application properly in a deployment environment, especially in production. So I'm going to worry about the logging and the monitoring and the network configuration and who's allowed to access this thing and how do you use it remotely and that sort of thing. So this way, dev worries about the application and that's the thing that goes inside the container. Ops worries about how that's going to run on the deployment platform. And containers are awesome. I really love these two pictures. The first one shows the container in that case is a big duffel bag stuffed full of stuff. And then on the right-hand side, the containers are all these big boxes that are stacked up on ships. And part of what's really nice about shipping containers is not only can you stack them up nicely in a ship, like shown here, but then you can pull a container off of a ship and put it on a railroad car and then move it on a train. And then you can pull it off of the railroad car and put it on the back of a truck and move it on a highway. And so containers are, shipping containers in the real world are very portable. And they're a nice standard that says it's always this size and it's going to contain like this amount of weight and those sorts of details. And then that way they're very portable, that you can move them on ships and on trains and on trucks, and you can even leave them sitting around in parking lots until you're ready to unload them. And the idea for computer software is that containers are likewise very portable. That they're a standard that says that as long as you decide to wrap up your software in this manner, then you'll be able to run your software in all these different sorts of places and move it around from one place to another very easily. And what containers really do is they isolate the differences between the applications inside the container, so that from outside the container, you don't really need to worry about how one application differs from another. One runs in Java and another one runs in Node, and another one isn't even an application. It's a database and things like that. For the most part, you don't have to worry about what's inside the container. You just need to worry, when it's just a container. And once it's there, then you just need to deploy it into a standardized environment. And so this really is a nice separation of concerns that makes it a lot easier to move around your software and use it in different places. This is kind of the history of containers, and one thing I find kind of interesting because IBM drew this. Normally, the history of containers starts in 2008 when Linux introduced the containerization feature. But because this is IBM, we start way before 2008. We say, well, hey, if you go back to 1982, the industry started introducing these sorts of features into Unix, such as Troop. That's kind of where this all started. And then there's all this other history of, if you look at what we were doing with virtual machines and with warpars and things like that, that really all of this was working its way up to what Linux decided to standardize as what they call containerization. And then Docker decided to standardize even further, to say, you know, part of the problem with Linux containers was there's lots of different ways of doing it, and it was kind of complicated, and you had to be kind of an expert in it to do it well. Docker said, okay, let's come up with one standard way of using Linux containers, and let's use that standard way so that most people don't really need to know how containers work real deeply. They just need to know how to use Docker, and as long as they know that, that's good enough. And so this has all been a march forward that's been going on for you know 30 or 40 years now, of being able to isolate a runtime environment and run it easily and move it around easily, and yet not have to be an expert in what the environment is, and separate kind of what goes inside the environment from how you're going to run the environment. So same idea, things just keep getting better and better. So we've talked a lot about portability. Let's talk a little bit about some of the other advantages of containers. And by that, we mean containers in general, and specifically Linux containers, and specifically Docker containers, which are one kind of Linux container. So what are the advantages? First of all, we've talked about portability, that once you build a container, any platform that has the engine for that container will then be able to run that container. And so that'll make it pretty easy. Second of all, containers are really easy to manage. And again, this is a place where Docker really excels, that Linux is good at in general, but Docker is even better, is that once you wrap up some software inside a container, then it makes it very easy to share that, to just say, here you go, it's already installed for you, you can run it on your machine. It makes it easy for you to download it from somebody else and know that you're getting the same thing. When you're not using it anymore, once you're through with it, it's very easy to delete it, and then you're not using it anymore. So again, the idea of software being hard to install, and then once you get it installed, it's hard to uninstall again. Well, containers make that a whole lot easier. And once you've got it installed, containers make it very easy to start the software and stop it again. So if you want the software running forever and ever, that might not be such a big deal. But a lot of times, especially the way things work in cloud, you don't want things to run forever. That instead, you want it to run for a while you need it. And then when you don't need it anymore, you don't want to run it anymore. Because if it's still running, it's taking up resources, and you're probably getting charged money for that. So containers make it very easy to, when you need more environments, to start up a bunch of them. And then when you don't need them anymore, to shut down the ones you don't need. And that is just really easy to do with containers and really hard to do without containers. Another neat thing about containers is they provide what we tend to call just enough isolation. And there's plenty of room to argue about this. And you know, maybe you can't satisfy all the people all the time. But in general, there's this belief that virtual machines provide a whole lot of isolation, but oftentimes it's too much, that they're very heavyweight. Containers are much, much lighter weight. And so compared to virtual machines, for a given amount of hardware, you can run a few virtual machines, or you can run a whole bunch more containers. Again, it sort of depends on what's in your containers. Your mileage may vary, but in general, the idea is that containers are lighter weight and you can run more of them. Now, the trade-off there is that they are not as isolated as the virtual machines, but the idea is that a lot of the isolation that virtual machines provide, you probably don't really need in a lot of cases. In the cases where you do need it, then fine, use virtual machines. But in a lot of cases, you don't really need that much isolation. You only need a little isolation or some isolation. And so containers provide enough. It's just enough isolation. And that's something that they continue to improve in containers in general and in Docker specifically, is figuring out where is that magic line of just enough and making it so that it's properly isolated. And what it means is that in general, you tend to use virtual machines and containers together. Is that oftentimes you take a really big machine with a lot of hardware, you use virtual machines to slice it into a couple of big slices, so maybe 3, 4, 10 virtual machines. And then within each of those virtual machines, you run a whole bunch of containers. So the virtual machines are sort of coarse-grained granularity, and the containers are sort of fine-grained granularity. And so the virtual machines you might use to divide things up for like different customers, that if you're doing multi-tenancy and you want to keep one customer's stuff separated from another customer's stuff, probably you would use two different VMs. They could be on the same hypervisor, on the same machine, but two separate VMs. But then within that VM, as that customer wants to be able to run a whole bunch of stuff, they can run it in different containers. And that way they can easily start and stop whichever containers they need. And that's a lot easier than creating new VMs. So a combination of things tend to be nice. And another nice thing about containers, or kind of a new idea, is that containers are often treated as though they're immutable. You don't absolutely have to do it this way. You can actually change a container, but the idea is don't. Two good practices on containers is, one, a container should only run a single process. If you need multiple processes, then run multiple containers. And two, containers should be immutable, or they should be run immutably. And that is the idea that once you deploy a container, you don't change it. Part of it is that containers are usually stateless. Now, it depends on whether you're talking about a container that is running an application or whether it's running a backend service like a database. If it's a database, it's certainly stateful, and that's a whole nother discussion. But a lot of what we're going to use containers for in Bluemix and that sort of thing is we're going to use it to run applications. And so part of the idea is that applications are stateless. And then part of the idea is that the container itself was immutable, so that it never really changes after you start running it. And furthermore, it doesn't contain any state anyway. And what that means is that when you don't need a container anymore, you can very easily get rid of it. And what that means is that when you've had a container running for a while, days, weeks, months is a really long time for a container. You usually don't leave a container running that long. But nevertheless, if you have one that's been running for a long time, generally you can say you know what its state is and what it's got and how it works, because it's been working that way since day one. It hasn't changed. What it means is that when you start up a bunch of containers that are supposed to be the same, they really are the same, because none of them change. They're all the same, and they stay that way. And this is because they're all created from the same image, and we'll talk a little bit about that. So you can have different versions of images, but what you don't have is different versions of containers. They're all created from the same image, or at least you know what image a container is created from, so you know whether or not two containers are the same or not, because you know whether or not they're created from the same image. And what this means is that you don't patch the container. So when a new version of the OS comes out, or a new patch for the OS, or a new patch for the Java runtime, or something like that, you don't SSH into the container and apply that patch. I mean, you can, but generally that's considered a really poor practice. That in general, what you're supposed to do is go back to the image, patch the image, and then deploy a bunch of new containers off of that image. And again, that way you know that the containers are always the same, and you know they're equivalent to each other because they all came off of the same image. So patch the image, don't patch the running container. That's a really good practice. So this is kind of what makes containers really cool and really useful, and why there's a lot of excitement about it.